Welcome to the Explainer! Today we're doing things a little differently. We are totally throwing away the idea that geometry is just some boring list of rules you have to memorize. No way. Instead, I want you to think of it as this incredibly powerful toolkit of logical cheat codes. We're literally going to become geometric detectives today. We'll use these specific shortcuts to solve visual puzzles and prove that shapes are exactly identical, without ever having to sit there and measure every single line and angle. Really, it's all about working smarter, not harder.
Okay, let's dive into this. Here is how we're going to break it down. First up, we'll meet the triangle. Then, we'll map out the anatomy of a triangle, explore the idea of congruency, unlock those 5 geometric cheat codes I mentioned, and finally, we're going to put the whole thing together by solving the puzzle.
Section 1. Meet the triangle, the basic suspects. Let's just quickly lay down the ground rules for the shapes we're investigating today.
Now, before we really get into the weeds here, I have a question for you. Every single triangle out there has 3 sides and 3 angles. That's 6 parts total, right? So if you're staring at 2 different triangles, do you really have to pull out a ruler and a protractor and physically measure all 6 corresponding parts to know for absolute certain if they're identical twins?
Well, the answer is no, you absolutely don't. And that brings us right to our ultimate goal for this explainer: congruency. When we say 2 triangles are congruent, it just means they have exactly the same shape, so matching angles, and exactly the same size, meaning matching sides. But measuring all 6 of those things manually, that is definitely the hard way. We want the shortcuts.
And this brings us to our first set of clues. There is this really intimate relationship between a triangle's sides and its angles. It's basically a built-in balance system. The rule goes like this. If the sides are all different lengths, the greatest angle is always going to be directly opposite the longest side. And on the flip side, if 2 sides are perfectly equal, then the angles opposite those sides, yep, they are perfectly equal too.
Section 2. Anatomy of a triangle. Internal landmarks. Before we can start comparing our suspects, we need to get familiar with their special internal features.
Now, what's really interesting about this slide is how it clarifies 2 terms that constantly trip people up: the median and the altitude. So, a median is a line that travels from a corner, or vertex, straight to the exact midpoint of the opposite side. It slices that side into 2 perfectly equal halves. An altitude, on the other hand, drops directly from the vertex to form a strict 90-degree right angle with the opposite side. The easiest way to remember this? Think of the median as the middle and the altitude as the height.
And here's where it gets really cool. When you draw all 3 medians or all 3 altitudes inside a single triangle, they always meet at a magic intersection point. For medians, that intersection is called the centroid. And I love this trivia fact: the centroid always divides each median into a precise 2-to-1 ratio, every single time. Now, for altitudes, that strict 90-degree intersection point is called the orthocentre. Knowing these landmarks, it's absolutely crucial for our detective work.
Section 3. The idea of congruency, the twin phenomenon. Let's really look at what it means for 2 triangles to be identical twins.
Okay, so the ultimate test of congruency is a concept called superposition. Imagine you have triangles ABC and DEF. If you were to literally pick up triangle ABC and place it directly over DEF, they would match perfectly. They exactly coincide. Every single side covers its corresponding side, and every angle sits completely flush over its corresponding angle.
Which leads us to the most powerful 5 letters in all of geometry: CPCTC. Corresponding parts of congruent triangles are congruent. Listen, once you prove that 2 triangles are twins using one of our shortcuts, you automatically know that every other corresponding piece is identical too. This right here is the golden rule. It's the ultimate punchline for almost every geometric proof you will ever encounter.
Section 4. 5 geometric cheat codes, the detective shortcuts. This is the fun part, where we learn the brilliant shortcuts mathematicians invented so we don't have to measure all 6 parts.
So, the crucial point is that you actually only need 3 specific pieces of information to prove a triangle is an identical twin. We have 5 mathematically rock-solid cheat codes to make this happen: side angle side, angle side angle, angle angle side, side side side, and finally, right angle hypotenuse side. Let's break these down one by one. First up on the list is SAS, or side angle side. If 2 sides and the angle right between them match 2 sides and the angle between them on another triangle, then boom, they are congruent. But hey, there is a massive precaution you need to keep in mind here.
That equal angle literally must be the included angle. It has to be trapped perfectly between the two equal sides, almost like a door hinge. If that angle is wandering off somewhere else, the cheat code totally fails.
Next up is ASA, angle-side angle. Think of this as the exact inverse of what we just talked about. If two angles and the side physically connecting them, so the included side are perfectly equal to the corresponding parts of another triangle, you've got identical twins. No further measuring required.
Then we have AAS, angle, angle, side. This is a really clever variation of ASA. Here, you have two equal angles, but the equal side is not sandwiched between them. However, you gotta be careful with this one. The equal sides absolutely must be corresponding. That means they have to sit opposite the matching equal angles in both triangles. If they don't correspond perfectly, it's a false match.
Now our fourth cheat code is just beautifully simple. It's SSS, or side, side, side. If you can prove that all three sides of one triangle are equal in length to all three sides of another, well, you're done. The triangles are perfectly congruent. You don't even have to glance at a single angle, because the rigid, locked-in structure of those sides actually forces the angles to match up perfectly anyway.
And our final shortcut for today is RHS, right angle, hypotenuse, side. Now consider this a VIP club exclusively for right-angled triangles. Because we already know for a fact that one angle is 90 degrees, we only need to find two other matching things: the hypotenuse, which is always the longest side, and literally any one of the other sides. If those two things match across two right-angled triangles, they are undeniably congruent.
Section 5, Solving the Puzzle, the Blackboard case study. Let's move on and see how this builds into a practical solution when we face a real-world puzzle.
All right, step into Mrs. Sharmila's classroom with me. She has drawn this large triangle, ABC, right on the blackboard to test us, and she gives us a few vital clues to start our investigation. She says line AD drops down and acts as a perpendicular bisector to the bottom baseline BC. She also tells us that line AD is exactly 9 centimeters long, and the entire bottom line BC is 24 centimeters long. Our detective mission? To prove that the left side triangle ABD is perfectly congruent to the right side triangle ACD.
Okay, here is exactly how we crack this case using our new toolkit. Step 1, let's unpack the phrase perpendicular bisector. Bisector means it cuts that bottom line BC perfectly in half, right? So we automatically know line BD is equal to line CD. They are both exactly 12 centimeters. Perpendicular means it creates strict 90-degree angles. So angle ADB equals angle ADC. Step 2, look for common elements. Well, both of these smaller triangles share the exact same wall right down the middle. That's line AD. Step 3, put it all together. We have a matching side at the bottom, a matching included angle of 90 degrees, and another matching side in that shared wall. Side, angle, side. By the SAS cheat code, triangle ABD is flawlessly congruent to triangle ACD. Case closed.
And just like that, without ever needing to measure the slanted outer lines or figure out those tricky top angles, we proved absolute perfection. It's like magic, but it's logic. Which leaves me with a final thought for you to chew on today. If geometry guarantees this invisible structural perfection using just a handful of simple clues, look at the architecture around you. Look at the bridges you drive over, or even just the roof above your head right now. Where are the unseen congruent triangles doing the heavy lifting and holding up the room around you at this very moment? Keep your eyes open, detectives. See you next time.